Alright, so the purpose of these videos, I guess, is while I continue to tutor you in person, these videos will give you a chance to go back and look at any older material you either forgot or want to just practice more. So, particularly, we're going to go back to the very first things we talked about in the arithmetic portion of the Accuplacer, and we're going to talk specifically about fraction rules. So, that's going to cover of course, adding, subtracting, multiplying, dividing fractions, all that stuff. And two more things we're going to cover is simplifying fractions and converting between improper and mixed number. So let's start by simplifying fractions. And you probably remember this. Yeah, I know you remember this because I've seen you do it before. But just as a refresher, and for anyone else who might watch this video, if I have one solid bar of chocolate, I'll draw another one down here. Okay. I tried to draw them the same, but just pretend they're exactly the same. Okay. So just look at this one for now. If I cut this in half, this would represent 1/2, right? Now what if I cut this into 6 equal pieces? 1, 2, 3. Okay. One, 2, 3, 4, 5. Okay. Again, pretend these are equal pieces. So here, if I shade this region in, that would represent 1/2, just as we said. If I shade this region, if I shade 3 of the 6 squares, that represents 3 out of 6, or 3/6. Now notice that this quantity and this quantity are exactly the same. So essentially this fraction simplifies to 1/2 because this fraction and this fraction represent the same quantity. So that's how we simplify. Now, without drawing pictures and without like if you're in the actual Accuplacer taking the actual test, here's how we probably want to do it. Again, let's take that 3/6 example. If I'm trying to simplify this, the way I do this is, what can I divide out of both of these that's the same number? So, or what's a factor? What's a factor of these two numbers? In this case, 3. I can divide out 3, I can divide out 3. So 3 divided by 3 is just 1, 6 divided by 3 is 2. Let's try another example. 2/8. Again, same idea. What's a factor of both of these numbers? That's the same. And in this case, notice both are even numbers. So if the denominator and the numerator are both even, 2 will always work. You can always divide out 2. So let's do it. Divide out 2, divide out 2. 2 divided by 2 is just 1. 8 divided by 2 is 4. So that's how I've simplified this as much as I can from this fraction. Let's try a fraction with bigger numerators and denominators. Alright, so I want you to try to pause the video and try to do this on your own. I'll give you one hint. Again, both the denominator and the numerator are even. So you can divide out 2. Now obviously that's not going to get you to the final answer. Like previously we divided out 2 and that got us straight to the final answer. Not in this case. You're probably going to have to divide out 2 again and again until you simplify all the way. So yeah, try simplifying this as much as you can. You'll probably notice that there's multiple ways. So pause the video, try to simplify it, and if you're stuck or if you're done, resume the video. So here's how this one goes. I'm going to show you two ways. There's multiple, I'm going to show you two ways. First way is, like we said, dividing out 2. So 12 divided by 2 is 6. 60 divided by 2 is 30. Both are still even. I can divide out by 2 again. 6 divided by 2 is 3. 30 divided by 2 is 15. Now, what's 3 divided, 2 won't work because neither of them are even. Now, another number will work this time, 3. So, if I divide out 3 divided by 3 is 1. 15 divided by 3 is 5. So now I've simplified this fraction completely. Let's go a different way. In fact, I could have actually, straight away, from the original fraction, I could have actually divided by 12 straight away. Because 12 is actually a factor of 60. 12 divided by 12 is 1. 12 divided by 60 is 5. And we got the same answer. Alright, so now that we've covered simplifying fractions, let's try converting between an improper fraction to a mixed number. And if you don't remember exactly what improper fraction means, it just means, in this case, you can already see something different about this fraction. The numerator is bigger than the denominator. Usually we're used to fractions like this, like 5 over 6. The numerator is always smaller. So that's how you already know that this is an improper fraction. So to change that from an improper fraction to a mixed number, all you gotta do is, so the way we're gonna do this is, how many times can 2 go into 3? So how many times can the denominator go into the numerator? In this case, 2 times 1 is 2. So 2 times 2 would be 4. That's too much. We've exceeded the amount. So in this case, it can just go in once. So 1 is the number that goes up front. The denominator stays the same, 2. Now, what number goes on top? So 2 times 1 is 2. 3 minus that 2 is just 1. So what goes on top is like what's left, basically. And we can try another example just to make sure that's clear. And again, this is a video, so feel free to pause, rewind, whatever. But pause and try to do this on your own, see if you can. So the way this is done, same idea. How many times can 2 go into 5? 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. So here we've gone too far. 6 is above 5, so it's not this case. 2 times 2 equals 4. That's the closest we can get. So 2 is the number that goes up front. The denominator stays the same. And 2 times 2 is 4. 5 minus 4 is 1. 2 and 1/2. Let's try one more example. Two more examples. So I got 6 over 2 and 11 over 3. So go ahead and try to change these to mixed numbers. Alright, so this one's actually pretty easy because how many times can 2 go into 6? Exactly 3 times. So that was it. And keep in mind, a fraction bar can also represent division. So what's 6 divided by 2? 3. Alright, so here, obviously 3 can't go into 11 evenly. So 3, again, let's try to see how far we can go. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 will be 12, so that's over. So we're going to stick with 3 times 3. The denominator stays the same. 3 times 3 is 9. 11 minus 9, 2. Alright, now let's try changing the other way around. From a mixed number to an improper fraction. This personally I find easier. It's just a lot faster. Alright. Our first example, 1 and 1 over 5. So all you do here, you multiply this number with this number and add it with this. So again, denominator stays the same. Now, 1 times 5 is 5. Plus 1 is 6. There you go. That's it. So let's try another one. So again, feel free to pause the video and try this on your own. So denominator stays the same. 2 times 3 is 6. Plus 2 is 8. So with the previous examples, we changed from improper to a mixed number. Here we did the other way around. Now, the reason why I'm showing you this is I don't think you'll get a question on the Accuplacer where it'll say simplify this, or it'll say change this to improper. The reason why I'm showing this is because when they will give you a question where they say add these two fractions together. Well, when you add them, you're going to have a fraction in the end that can be simplified, or it's an improper fraction, and the answer choice is not going to show you your answer. So you need to simplify, you need to change it to a mixed number. So again, there's not a question specifically for these, but you'll need these skills to correctly answer questions that they will have. So now let's talk about adding fractions, and there will be these questions on the Accuplacer. So alright, so in the arithmetic portion of the Accuplacer, chances are you're probably going to see a question pretty much like this. It'll just say find the sum, and it'll give you two fractions and a plus sign. So you're going to add them together. Alright, so for adding fractions, actually let me this up here. Alright, so I'm going to break up our fraction rules between adding and subtracting, multiplying and dividing. It's probably a good idea to maybe make like flashcards out of these if you like. Alright, so for now we're going to talk about adding and subtracting fractions. So with both of these cases, adding and subtracting, they follow the same rules. With both of these cases, you need something called a common denominator. I hope that's big enough to see, I don't know. But for adding and subtracting fractions, you always need something called a common denominator. And the name implies its meaning. It just means that the denominator in both your fractions needs to be the same. So let's take an example. Okay. Alright, so with the help of multiplication, what is something I can multiply with any of these fractions so I can, basically the end goal is to get these to look the same. So now this one is pretty easy because I can multiply this fraction with 2, the top and the bottom with 2. That way, if I do that, I'll get 1 times 2 is 2. 2 times 3 is 6. Now I didn't multiply anything with him, so he stays the same. Boom, I got common denominators. 2 plus 5, 7 over 6. Oh, so you add the top numbers, you don't do anything with the denominators, it stays the same. Now notice this is an improper fraction. So when you get to the multiple choice questions in the Accuplacer, this is not going to be on there. But you have the right answer, you just need to go a little further. So let's do what we did before and change this to a mixed number. How many times can 6 go into 7? Just once. 6 times 1 is 6. 7 minus 6 is 1. And denominator stays the same. This would be your final answer. Okay, so we got three parts here. We're adding three numbers. These two fractions and this mixed number. So some people try to get common denominators in all of these and just like do it in one shot. If you see the chance, like if you see it's easy, go ahead and try it. But personally, I just like to take it one at a time. So I add these two numbers first. Once I found my answer, I go back and add it with this. So I'm kind of finding common denominator just one at a time. So that's what I'm going to do here. I'm going to add these two numbers first. So 1 over 3 plus 3 over 4. So here, with the previous example, I only had to work with one fraction. Here, that's not going to work. I gotta multiply something with both of these fractions. So a really easy trick is just multiply this fraction with what you see here, multiply this fraction with what you see here. So I'm multiplying 1 over 3, both the top and the bottom, with 4. I'm multiplying the top and the bottom here with 3. So 1 times 4, 3 times 4, 12, plus 9, 4 times 3, 12. So I got my common denominators and I'm good to go. So I just add 4 plus 9 is 13. 13 over 12. Okay. Now I'm not done yet because I still have this guy to take care of. Now before I move on, technically you don't have to. You don't have to do this. So what I'm gonna do is I'm gonna change this to a mixed number first, and then add it with this. But you don't have to. This can stay as an improper fraction, and so in the end you'd have like this: 13 over 12 plus 2 1/2. You do the same as you always do when you're adding fractions. You need common denominators. Actually, let's do it both ways. So in this case, I kept my answer as an improper fraction. I'm gonna keep going. So I need common denominators, and in this case, I can multiply this fraction with 6. So I'll be left with, I didn't do anything with him, so 13 over 12 times, plus 2, 1 times 6 is 6, 2 times 6 is 12. So I got my common denominators. I'm going to add 13 plus 6 is 20 and 90? 19. And so the 2 stay the same because there's no number out front to add with the 2. So 2 stays. 19 over 12. And now I've got an improper fraction within the mixed number. So I don't need to panic, it's just the same thing. So how many times can 12 go into 19? Just once. So that 1 gets added to the 3. So you get 3 and 19 minus 12. 17. Yeah, 7 over 12. Okay, so this is our final answer. If we went this route, let's go the other route. Let's change this to a mixed number and then add it with this and see if we get the same answer. So this is a mixed number. 12 goes in 13 once. It should be 1 over 12. Okay, plus 2, 1 over 2. All right. Same thing. Multiply with this 6 times 6. So that'll be 1 over 12 plus 2, 6 over 12, 3, 7 over 12. I got the same answer. Okay. Both ways work. It's just whichever one you feel like doing. There's no preference here. All right. So let's take a look at some subtraction examples. Now, even though it's subtraction, it's the same rules. You still need common denominator. So same thing, I can multiply this with 3, this with 3, that'll give me 5 over 6 minus 3 over 6. Okay. Now instead of adding, obviously I'm going to subtract. So 5 minus 3 is 2. The denominator stays the same. And this can simplify. I can divide 2 out of here and 2 out of here. Okay. So that would be my final answer in this case. Now, the only catch with subtraction is sometimes you'll see a question like this. So I want you to pause the video and do this on your own, and you should run into a problem. I mean, if you know how to handle it, then go ahead. But you should run into a problem, and if you can't figure it out, resume it, and we'll go over it. Okay, so same idea, common denominators. So in this case, I'm going to multiply this by 2 and this by 3. 2 times 2 times 3 times 3. Okay, so that's 2 and 2 over 6. No, not close. 3 over 6. Okay, so I got my common denominators. The only problem is I can't do 2 minus 3. I'll get a negative fraction. So yeah, I can't really do 2 minus 3 here. So what I do is something called regrouping. So I'm going to take one whole off of him. So you just pick 2 minus 1 is just 1. I'm going to add that whole back onto here. So I don't add 1, I add 6. In this case, 6 is a whole. So I add 6 onto the 2. So it becomes 1, and 6 plus 2 is 8. 8 over 6 minus 3 over 6. Now I can do 8 minus 3. So that's 5. Okay. And this can be simplified. That's our final answer. Okay, so that's about as far as it goes for adding and subtracting. Some common mistakes here I've seen are, so most of the times students will do all the work correctly, getting all the common denominator and stuff like that. They'll do it all correctly, no problem there. It's just that at the end, like let's say it's a subtraction problem, they'll forget that it's a subtraction problem and add the numbers. So just make sure you, with all the amazing work you're doing, just make sure like what the question is actually asking. If it's adding, add. If it's subtract, subtract. All right, so let's look at multiplying now. So personally, I think multiplying fractions is the easiest because you just multiply straight across. So I'll show you what that means. The only thing though is, remember with the addition example we did, we worked with, I can rewrite it. It was, I think this is it. Okay, so with this example, notice how we had some fractions and some mixed numbers. So if this were a multiplying question, you have to change any mixed number you see to improper form first. That's the first step you do. So if this was multiplying, the first thing I'd do is change this to improper form. Alright, so that's the only rule for multiplying. You need to have your fractions in improper form. So let's give it a shot. Let's give this a shot. Alright, so with adding and subtracting, we added and subtracted the top numbers and we kept the denominators the same. With multiplying, you just multiply straight across, the top and the bottom. Multiply straight across. 7 times 3 is 21. 10 times 5 is 50. That's it. I don't think this fraction can simplify. Yeah, I don't think it can. So that's your final answer. That's it. One common mistake I see is like, if students forget exactly what the rule is, they'll cross multiply. So they'll multiply, instead of straight across, they'll do this, which is not correct. Don't do that. Multiply straight across, don't cross multiply. All right, let's try another example, this time with a mixed number. Okay. So as we can see here, we don't need we don't find common denominators anymore. That's only for adding and subtracting. Okay. Well, like I said, we have a mixed number, so we need to change it to improper form first. So let's do that. 5 times 1 is 5, plus 1 is 6. So this becomes 6 over 5. And this is good to go. We don't need to do anything with that. So now that we have that, multiply straight across. 6 times 2 is 12. 5 times 5, 25. I don't think that can reduce either. I think that's, yeah, it's good as it is. Let's try one more. Two more. All right, and again, I'm going to keep reminding you, this is a video, so pause it, try to work the examples on your own, and whenever you get stuck, just resume the video and kind of play it through. All right, again, same thing. This time both are mixed numbers, so we need to change both to improper form. 5 times 2 is 10. 10 plus 2 is 12. So 12 over 5 times 2 times 3 is 6. 6 plus 1 is 7. So 7 over 2. Okay. Multiply straight across. 12 times 7, 84, I think. Yeah, 84. And 5 times 2 is 10. So obviously we got some, it's two things. It's improper and it can actually simplify as well. So it doesn't matter which order you do it in. You can change it to improper first or you can simplify first. It doesn't matter. Personally, for me, it makes it a little easier to simplify first. So you're not dealing with such big numbers. So both of these are even, so we can divide by 2. So that'll be 10 divided by 2 is 5. 84 divided by 2, let's see, 42. Okay, now I don't think that can simplify anymore, so let's change it to a mixed number now. Okay, 5 can go into 42, so 5 times 8 is 40, so 8. 42 minus 40 is 2, there we go, that's it. So, of course, we did not stop. We didn't stop here because, again, this is multiple choice. So, I don't think any of your multiple choice answers are going to look like this. They're going to look something like this. So, don't wait. If you have an improper fraction or a fraction that can simplify, don't stop there. Keep going, and simplify it or change it to mixed number, and that will be your final answer. Okay, let's try one more multiplication problem. This one is with a whole number. So let's do Alright, so anytime you're dealing with one whole number and a fraction, it's a good idea to just to change this to a fraction. Now the way we change a whole number to a fraction, we just put it over 1. So to change this 3 to a fraction, I'm which we're going to do 3 over 1. Because in the end, 3 divided by 1 is 3. So I didn't change the value, I didn't break any rules. And this is the same, 4 over 5. Okay, so this is not a hard question. I just want to make sure you can change a whole number to a fraction. That's really all I wanted to do. Because this is easy. You just multiply straight across. 3 times 4 is 12. 5. Obviously, you can change this to a mixed number. Twice. Alright, yeah, because 5 can go into 12 2 times. 12, so 5 times 2 is 10. 12 minus 10 is 2. Alright. Now let's look at dividing. Okay, so two rules we need to memorize for dividing fractions. One of them is same thing as multiplying. It needs to be in proper form. The other rule is something called keep, change. You can't, I don't think you can see that. So, change in proper form, and the second rule is something called keep, change, flip. If you don't remember what that is, we'll talk about it. I'll show you what it is. So let's look at an example. Okay, I'm going to make that a little more. I'm not really sure if you can see this very well. Hopefully you can. Okay. So lucky for us, this is already in improper form, so we don't need to change it. That's good. Don't change it to mixed number, because with multiplying and dividing, they need to be in improper form. So let's go ahead and do this. So now that the first part is done, let's go on to the second part. The second step is keep, change, flip. So that means keep the first fraction just as he is. Keep, change to multiplication, flip this fraction. And now it's like a multiplication problem. 1 times 4 is 4. 8 times 5 is 40. This can obviously be simplified. I can divide by 4. Or I could have gone the other way, because both of these are even, so I could have divided by 2 and then by 2 again. Alright, so again, this is a video, so if there's something you didn't understand, just rewind, play it again. Again, we're going to go through more examples, don't worry, this is not the only one. But rewind, play again, ask me any questions next time you see me, whatever, either way works. And so let's try this example. Again, pause the video and try to do it yourself, see if you can do it yourself. Okay, so going by our steps, we change to improper form first. And in this case, yes, we do. We have a mixed number. So 3 over 4 stays the same, divided by 1 times 2 is 2. So right, denominator is the same. 1 times 2 is 2, plus 1 is 3. Okay, so I've done the first step. Move on to the second step. Keep, change, flip. Keep, change to multiplication, flip. Alright, 3 times 2 is 6. 4 times 3 is 12. 1/2. Make sure I do that. Yeah. Okay. Alright. So obviously I couldn't I couldn't show you dividing fractions without showing you multiplying fractions, because in the end it becomes a multiplication question. That's just the way it is. That's the way it works. All right. Let's try one more. Okay, so going off your knowledge from the last example we did with a whole number, try to pause the video and try to do this. Change this to a fraction. Alright, so here's how you do this one. So first thing is I'm going to change this to a fraction. I'm just going to put it over 1. Alright, there's no mixed numbers, so I can skip the first step and go on to the second step. So keep, change, flip. 3 times 1 is 3. 3 times 5 is 10. There you go. That's it. So now that we've covered simplifying, we've covered changing between improper and mixed number, and we've covered adding, subtracting, multiplying, dividing. Here's some common mistakes I see with all these problems. A lot of times when students go to the test, they forget a lot of the basic fraction rules, and a lot of times they'll multiply. When they're multiplying, when the original question is multiplication, they'll do keep, change, flip. So you're not supposed to. No, you get the wrong answer that way. So it's really a good idea to like make flashcards from now. So if you're adding, subtracting, what's the rule you need? Common denominator. If you're multiplying, the only thing you need is to check to make sure everything's in improper form, if there are mixed numbers. If you're dividing, that's when you do keep, change, flip, in addition to changing everything to improper form. So one last thing I want to leave you off with. Now that we know all these rules, in the Accuplacer, you are going to see questions just like I showed you. It's literally going to ask you, what's this fraction times this fraction? But let's take a look ahead into the later sections. I know with you I've gone over solving equations, so let's take a look at an example with solving equations. So if we have a one variable equation, I know this is a very simple example. 0, yeah. So how do we solve this? Subtract by 2, subtract by 2, x equals 0 minus 2 is -2. So I just want to make sure you're still fresh on that. So I've seen this in the Accuplacer where they'll toss in fractions into these questions. So instead of nice clean whole numbers like that, you'll see something like this. Something like that, for example. So how would you solve this? Same idea as solving a regular equation. So there's subtraction, so you add 3 over 2, and you add 3 over 2. So these cancel out, and you have this fraction plus this fraction. Now we use our adding rules. So 1 over 3 plus 3 over 2. Again, this is an improper fraction, so I can leave it, or I can change it to mixed number. I mean, in this case, I'm just going to leave it. So I still need common denominators, so I'm going to multiply this by 2, and multiply this by 3. So I'll get, this becomes 2 over 6, 9 over 6. So I got my common denominators. 2 plus 9 is 11. So obviously I change this to a mixed number. Now 6 times 2 is 12, so I can only go in once. And denominator stays the same. 6 times 1 is 6, 11 minus 6 is 5. So that would be my final answer. So x in the end would equal 5 over 6. So now they still get harder than this, but this is why you see fractions not only in how do you say, like, not only will there be questions where it literally tells you divide these two fractions, there'll also be questions in the later section in college algebra and stuff like that where there'll be a question like this. So they'll toss in fractions into solving a question. Now obviously if a different person is watching this video and you haven't done solving equations yet, don't worry, we'll talk about that later, don't worry. So yeah, that's it for this first video. Hopefully this will help you jog your memory, so this way we don't have to keep going back. Once I'm done with all the arithmetic videos, I'll give like a packet you can work on just to make sure you're fresh on all the stuff.